Every backend developer needs to learn Java Spring Boot at some point. The Spring framework has evolved from a single developer's vision into one of the most influential enterprise frameworks. Spring is a comprehensive framework for building Java applications, providing everything from dependency injection to web development tools. But to understand why Spring Boot matters so much, we need to understand where it all began. Let's start with J2EE, Java 2 Platform, Enterprise Edition. J2EE was Sun Microsystems' platform specification for building large-scale distributed enterprise applications in Java. It was released in 1999. It provided a comprehensive set of specifications and APIs for multi-tier architecture. The platform included serverlets and JCP for web presentation, AGB for business logic, JDBC for database access, JMS for messaging, GTA for transactions, JNDI for naming and directory services, and Java Mail for email. The idea was to create a complete standardized enterprise platform. Let's go over them one by one. The servlet, HTTP requests and let's go over them one by one. Serverlets handles HTTP requests and generate response. The annotation web serverlet maps this serverlet to the slash products URL in the example above. Init method is called once when serverlet is first loaded and used to initialize resources like the product service in the example above. DoGet handles HTTP GET requests, extracts action parameter to determine what operation to perform. Request and response objects encapsulate HTTP input-output. Serverlet must manually parse and populate them. Let's move on to JSP, which is a mix of HTML and Java code for presentation logic. JSP files mix HTML markup with Java code for dynamic content generation. JSTL, JSP standard tag library, provides tags like CF and C for each for logic and iteration. Expression language with the $sign syntax accesses data from requests or session scope. Products data must be set as a request attribute by the servlet before forwarding to the JSP page. Let's go to the AGB, Enterprise Java Beans, business logic in managed transaction environment. The stateless annotation indicates that AGB does not maintain conversation state between method calls. Persistence context annotation injects a container managed entity manager for database operation. AGB annotation injects another AGB, allowing the service to call inventory service in the example above. Transaction attribute ensures the entire method runs in a transaction and rolls back automatically on exception. Then we go to JDBC for database access. Data source provides database connection from a managed connection pool. Prepared statement with the question mark placeholder prevents SQL injection attacks. Set string, set double, set int methods bind parameters safely to the query. Try with resources automatically closes connection and prepares statement to prevent resource leaks. Then we move on to JMS, Java Messaging Service, messaging for asynchronous communication. Resource annotation injects JMS resources, which is connection factory and the queue, from JNDI server registry. Connection factory creates a connection to the message broker. Session creates messages and producers. Object message wraps the order object for transmission. Order must implement serializable. Messages are sent asynchronously. Sender does not wait for the receiver to process the message. GTA, Transaction Management. User transaction provides manual control over transaction boundaries across multiple operations. Spring emerged from Rod Johnson's experience with J2EE development. In October 2002, he published Expert 1-on-1 J2EE Design and Development, which included about 30,000 lines of infrastructure code demonstrating alternative to the complex AGB model that dominated enterprise Java at the time. This code became the foundation of Spring. The key insight was that most applications did not need the heavyweight complexity of the full J2EE application servers. Johnson advocated for a simpler approach, centered on dependency injection and plain old Java, objects or POJs. Joran Holler, a reader of Johnson's book, contacted them about the code samples and became a co-founder. Together with Diane Karov, they released Spring Framework in zero point 0.9 in June 2003. The first production-ready release, version 1.0, arrived in March 2004. The core philosophy is Spring was built around several revolutionary concepts for its time. Dependency injection, rather than objects creating their dependencies, Spring would inject them, promoting loose coupling and testability. Aspect oriented programming. Cross cutting concerns like logging and transaction could be separated from business logic. Pojo based development. Unlike AGB, Spring worked with plain Java classes, making development simpler and more portable. Let's go over them one by one. This example is without dependency injection. Order service directly instantiates Gmail email service and Stripe payment processor with the new keyword. This creates tight coupling, which is impossible to swap implementation without modifying the order service code. Testing is difficult, cannot mock dependencies, must use real Gmail and Stripe in tests. Violates dependency inversion principle. High level module depends on concrete low level implementations. Now an example with dependency injection. Server's annotation marked this class as Spring Managed Bean. Spring creates and manages its lifecycle. Auto-wired annotation tells Spring to inject dependencies through constructor, promotes immutability with the final keyword. Order service depends on interfaces, not concrete classes, can swap implementation via configuration. Spring handles object creation and wiring. Order service never uses the new keyword for dependencies. Now an example with easy testing with dependency injection. We use Mokito's mock method, create fake objects that stimulate real dependencies without actual implementation. Constructor injection allows easy substitution of mocks, no Spring container needed in tests. Verify method confirms the service called methods with expected parameter, tests behavior, not it tests behavior, not implementation. Unit tests run fast and in isolation, no real email sending or payment processing. AOP. This is an example without aspect-oriented programming. The core business logic is buried in cross-cutting concerns like logging and transaction. Same logging and transaction code would be repeated across many service methods. Violates dry principle. Changes to logging format and or transactions behavior require editing every service method. Hard to maintain. Mixing multiple responsibility makes code harder to understand and test. AOP. Now aspect-oriented programming. Transactional annotation applies transaction management automatically. Spring grabs method with begin, commit, and rollback. Loggable triggers logging aspect to run. Aspect executes before and after the method without modifying service logic. Transactional annotation applies. Annotation applies transaction management automatically. Logging triggers logging aspects to run. Around advice intercepts method execution. Cross-cutting concerns are centralized in aspects. The Pojo-based development. In AGB, it required multiple interfaces, complex deployment descriptors, lifecycle method implementation, lots of boilerplate. Spring Pojos, just plain Java classes, simple annotation, focus on business logic. Here's an example of a Spring Pojo. No complex AGB interfaces or deployment descriptors, just service annotation makes it Spring managed. Transactional provides AGB level transaction management with a single annotation. Account repository Account repository interface extends GPA repository. Spring Data GPA auto-generates all the CRUD methods. Plain Java class with minimal Spring annotations. Plain Java class with minimal Spring annotations, highly testable, no container dependency in code. Spring Boot is a framework built on top of Spring Framework that radically simplifies the process of creating production-ready Spring applications. Released in 2014. It eliminates most of the configuration overhead that made traditional Spring development time consuming. The core concept is Spring Boot follows an opinionated approach with convention over configuration. It makes intelligent assumptions about what you are trying to build and auto configures your application accordingly. If you add a database driver to your project, Spring automatically configures the connection port and the data source. If you include a Spring MVC, it sets up a web server and configures all the necessary components. The key features of a Spring Boot. Embedded servers. Spring Boot applications include embedded web servers like Tomcat directly in the executable jar. Auto configuration. Based on the libraries in your class path, Spring Boot automatically configure beans and components. As Spring Boot starter data GPA, and you get a configured GPA setup without writing any configuration code. Starter dependency. Pre-packaged dependency bundles that pull in everything needed for the specific functionality. Instead of manually managing dozens of compatible library, you add one starter pack and get all web-related dependencies. First, we see the adding of the dependency. We added two dependencies here: Spring Boot Starter Data GPA and MySQL Connector Java. And now we configure the database. And we have an application.properties file that contains all the key value pairs uh, of our environment. We add the necessary fields like URL, username, and password, and directly be able to use them. Now we move on to why Spring Boot exists. The configuration burden. Traditional Spring, while simpler than J2EE and EGB, still require substantial configuration. Developers spent hours setting up projects, configuring XML files, managing dependencies, and dealing with deployment descriptors. This was especially painful for microservices, where you might have dozens of applications, each running the same setup. The microservice movement. As a microservice architecture gained popularity around 2010 to 2014, teams needed to create many small independent services. The traditional Spring setup process became a bottleneck. Each service needed its own configuration, deployment setup, and infrastructure code. Developer productivity. The Spring team recognized that most applications follow common patterns. Why should every developer repeatedly configure the same components? Why can't the framework make intelligent decisions based on what's in the project? Modern development experience. Developers come from frameworks like Ruby on Rails and Node.js expected faster development cycles, simpler deployment, and less boilerplate. Spring needed to modernize to stay competitive. Why use Spring Boot? Rapid development. You can go from zero to running an application in minutes instead of hours or days. Microservice ready. Each Spring Boot application is self-contained with its embedded server. Production features built in, health endpoints, metric collections, application monitoring, and externalized configuration come out of the box. Flexible configuration. While Spring Boot provides sensible defaults, you can override any configuration through properties files, YAML files, and environment variables. Strong ecosystem integration. Spring Boot Starter exists for virtually every popular technology: database, messaging, security, cloud platform, and more. Reduced maintenance. With Starter dependency managing transitive dependency, you avoid version conflicts and compatibility issues. Spring Boot handles the complexity of maintaining compatible library versions. The real world impact. Spring Boot transformed Spring from a framework requiring expertise to configure into one that beginners can use productively within days. Companies can build new services faster, deploy more easily, and maintain applications with less overhead. A typical enterprise now runs hundreds or thousands of Spring Boot microservices, each deployable independently, each with minimal configuration. What once required dedicated build and release teams can now be handled by the development team. The modern standard. Today, when people say Spring, they usually mean Spring Boot. Spring Boot is used over 70% of Java developers, and powers millions of applications worldwide. It became the de facto of standard Java backend development, powering everything from startups to major enterprise systems like, uh, like Netflix, Amazon, and Alibaba. Spring Boot didn't replace Spring. It made Spring accessible, practical, and aligned with modern development practices. It proved that you could have both the power of enterprise feature and simplicity of rapid development framework. In the next video, we'll build our first Spring Boot application from scratch and see exactly how these auto configuration works in action. You'll experience firsthand why Spring Boot has become the go-to choice for modern Java development.